Okay, this is just a video to try and make Chapter 8 a little bit more interesting. We need to mainly know about diamond and graphite for the sac, but there's all these other types of allotropes of carbon in the textbook. You need to understand that what an allotrope is and how the different structures give the different properties. So, uh, what does a carbon atom look like? Remember, carbon has got 6 protons, 6 electrons, 2 electrons in the first, 4 in the second shell. So it needs 4 more electrons. So it will make 4 different bonds. So our carbon atom always has to have 4 lines coming out of it. An allotrope is uh, an element, so it's like an isomer. An isomer has the same formula, but a different way of putting those atoms together. So an allotrope is like an isomer, but it's just one element, so one type of atom. So the one that we're looking at for Chapter 8 is just carbon, the element carbon, but you can have allotropes of oxygen or other phosphorus. You can have different arrangements of how the particular elements put together. So this chapter is only looking at carbon, and there's a lot of different ways of putting carbon together. So mainly we want to concentrate on diamond and graphite. So I'll show you a quick video here.
Right in our giant covalent structures lesson, you may have learned about the structure of diamond and graphite. These two substances are made of only carbon atoms, yet they exhibit very different physical and chemical properties. A diamond is very shiny, remarkably strong, and does not conduct electricity. Graphite is black, not nearly as strong as diamond, and can conduct electricity. These differences are due to the arrangement of carbon atoms within the structure. Each carbon atom in diamond is covalently bound to 4 other carbon atoms in a tetrahedral structure. Each carbon in graphite is covalently bound to 3 other carbon atoms in a trigonal planar structure forming hexagonal sheets. Some other allotropes of carbon include the Buckminster fullerene molecule and graphene. You can learn more about these structures right now.
Okay, so the different ways that carbon atoms are bonded together makes the different properties. So diamonds are when the carbon atoms, each carbon atom is bonded to 4 other carbon atoms in a 3D arrangement. It makes it really hard. It's the hardest natural substance. And they use diamonds to coat the end of drills and because of its hardness. So this is showing the bonding. This carbon atom here is bonded to 4 other carbon atoms, and I'll show you a video of it rotating. Okay, so this is diamond, lots of carbon atoms all bonded together in a 3-dimensional arrangement. So that's what diamonds look like. You notice that depending on where you turn it, you can see through the diamonds, through the diamond. So here you can see the structure. If we pick an atom, so this particular carbon atom, you can see that it's bonded to 4 others. And that structure, that tetrahedral structure, is repeated over and over and over again. So diamond, that's this 3D structure is why diamond is really strong. Okay, so now we'll look at what your pencil is actually made out of. So it's made out of graphite. So graphite is like diamond in that you've got these rings. You notice the rings on diamond before. So the carbon is bonded to other carbon atoms, but instead of being bonded below, you've just got layers of these rings. So this layer is not bonded to the layer below. So this carbon atom could bond with that carbon atom if they were in the right positions, and then that would make diamond. but they're slightly in the wrong spot. So the electron that would be shared with this carbon atom's electron to make a bond is not being shared. So this electron and the electron from here are free to move. So they're not fixed in a bond. So because, like metals, electrons that are free to move are called delocalized electrons. So the third electron, so if we looked at this atom here, this is showing that it's bonded to 3 carbon atoms, but not down to the 4th. So this electron and this electron, they're moving. So they move between the layers here, and they're delocalized electrons. So because they move between the layers, graphite can conduct electricity. So your pencil, if you put an electrode on one end of the pencil and an electrode on the other end of the pencil, it would conduct electricity. Okay, so graphite's what's in your pencil. So it's made of layers of those rings of carbon. So the reason that you can put pencil on a piece of paper is because when you're rubbing it on the paper, the layers come off onto the paper. So now the paper is covered in layers of pencil, layers of graphite. Okay, so those layers of graphite have got electrons that aren't bonded, so they're free electrons. So the pencil will conduct electricity. So they're going to show it, and I'll just pause it and move it along. Okay, so they've put wire on either end, and they've got a light globe here. So when they put the wire on the graphite, the electrons are running through the wire and through the along the graphite and through the light globe, so they can conduct electricity. Okay, there's a whole lot of videos on people getting the graphite out of pencils and then putting electricity through until it glows. So this person's got 2 batteries and they're going to link them together and then run the electricity through the pencil lead that they've taken out of a pencil. So it's graphite, so it's layers of carbon, and the electrons are running through those layers until it's glowing. So your pencil will conduct electricity. This almost looks like it's starting to burn, the carbon's starting to burn. Okay, so as well as organized diamond, which is organized in 3 dimensions, and layers like graphite, the book talks about amorphous carbon, where it's not organized. So you've got layers, but then the layers aren't even, they're all just muddled together. So coal is like that, amorphous carbon. It's just a bit of a mess, and the textbook also talks about activated charcoal. So that's got layers and it's got other things bound onto the rings. So there's a whole lot of different sorts of carbon.